Okay, let's take a look at section 1.2 where we're going to actually solve some linear equations. Looking at number 10 from your textbook, what we're going to do is we're going to simplify each side as much as possible. So starting in the left side on number 10, I can't simplify within the parentheses, so I'm going to distribute. 2 times positive x gives me 2x. 2 times a negative 1 is negative 2. I still have a positive 3 on that side. So let me add my like terms. I'm going to add negative 2 and positive 3. And that's going to give me a positive 1. Now I'm going to concentrate on the right side. Again, I can't simplify with inside the parentheses, so I'm going to distribute. This time I'm distributing a negative 3. So negative 3 times x is negative 3x. Be sure to carry that sign. A negative 3 distributed to a positive 1 is negative 3. So if I add a 1x and a negative 3x, those are like terms. That gives me minus 2x. I still have a negative 3 left on that side. So now let's get our variables on the same side. So if it's a minus 2x and I want to take it to the other side, the opposite of subtraction is to add. That's going to get that to cancel out. Think of that equal sign as a boundary. When you cross over it, you have to do the opposite. These are going to cancel out, give me negative 3. 2x plus 2x is 4x. So I have 4x plus 1 equals 3. I'm trying to isolate the variable and get it by itself. So I need to move positive 1 to the other side. So I'm going to subtract. So we get 4x equals negative 3 minus 1, which is negative 4. It's 4 times x. So I'm going to divide both sides by 4. Those are going to cancel out. And my answer is negative 1. Notice that the directions say to solve and check your equation, so I'm going to allow you to do that, but you can plug in the negative 1 back into your x, and the left side of the equation should equal the right side. 16 looks fun, doesn't it? So what we're going to do with 16 is we're going to simplify the left side as much as possible. I'm not even going to worry about the right side right now. So working within the brackets, I'm going to take care of all of my distribution. Negative 4 times y is negative 4y. Negative 4 times 7 is negative 28. So let's add our like terms. Negative 2y plus negative 4y is negative 6y. And a positive 4 added with a negative 28 is negative 24. So I've simplified as much as possible within those brackets. So now I'm going to distribute that negative so that I can get rid of the brackets. So negative times negative, that is positive 6y. Negative times negative is positive 24. Add my like terms. 45 plus 24 is 69. Now let's come over to the right side. And I'm going to simplify the right side as much as possible. So starting with the first, negative 4 multiplied by 1 plus 3, I can go ahead and distribute that. Being careful with your signs. And I'm going to keep my brackets until I absolutely do not need them anymore. So I'm going to start working within the brackets, and I'm going to go through and I'm going to distribute, again, carrying my signs. Negative 3 times a positive y is negative 3y. I get minus 6 minus 4y plus 10. All that is within our brackets, distributing both of those. So let's go and let's clean up our bracket a little bit. Negative 3y and negative 4y gives me negative 7y. And 4 and negative 6, if I add those, I get negative 2. Negative 2 plus 10, I get 8. Now I'm going to distribute my negative to get rid of those brackets. And now let's add. Negative 4 plus a negative 8 is negative 12. Negative 12y and a positive 7y is negative 5y. Now we've cleaned up the left and the right side completely. So now let's get our variable on the same side. So I'm going to move the minus 5y over. So 6y plus 5y is 11y. Those are going to cancel out on the right side. I'm going to subtract 69 from both sides. I get 11y equals negative 81. And then I'm going to divide both sides by 11. So we get negative 81 divided by 11 as my final answer. You can leave your answer as a fraction. We just want to make sure that the fractions are reduced as much as possible. I chose that one because it was the most complicated of the examples that they gave you in your textbook. So I'm confident that if you can do one like 16, you should be able to do any type of equation that I would ask you to solve. All right, so let's look at another example. We're going to solve a linear equation that has fractions in it. So to do this, the easiest way to solve an equation with fractions in it is to look at the denominators that I have. In this case, I have a 3 and a 2. What is the first common multiple that 3 and 2 have in common? That least common multiple is 6. So what I'm going to do is I'm going to multiply every term by that least common multiple. So that means whether the term is a fraction or not, I'm going to multiply it by it. The trick with that is when you multiply by the least common multiple, it's going to get rid of all the fractions. So 6 times 20, or 6 times 20 is 120. Look what's going to happen here. 3 goes into 6 2 times. 2 times x is 2x. 2 goes into 6 3 times. 3 times x is 3x. So the beauty about this is when you multiply by that least common multiple, it takes away all the fractions. So let me add 2x to both sides. Doesn't matter on which side I isolate that variable as long as I get it by itself. So 120 equals 5x. Divide both sides by 5. Those are going to cancel out. And our answer ends up being 24. So when asked to solve equations that have fractions in it, multiply by that least common multiple. All right, so let's try a little bit more difficult one. Here we still have fractions. I notice that I have expressions in my numerator. So I always like to, if I have expressions in my numerator, I like to go ahead and put parentheses around those. Sometimes it keeps students from making some common little mistakes. So I look at 4, 6, and 3. The first multiplication fact that they all have in common would be 12. So I'm going to multiply every one of these terms by 12. And if we do this correctly, I should not be left with any fractions. Okay, so let's see what happens. 4 divides into 12 3 times. So 3 multiplied by, let me just write this extra step. I'll just write it like this. 6 goes into 12 2 times. 2 times 1 is 2. 3 goes into 12 4 times, so that leaves 4 times 2 minus x. When you multiply by that common denominator, or that least common multiple, all your fractions go away. Now we can simplify by distributing. 3x plus 3, 2 plus, I'm going to distribute the last part. I get 8 minus 4x. Anytime that I can clean up like terms, I'm going to do that. Going to get my variables on the same side, so that means adding 4x. So 7x plus 3 equals 10. Remember, you have to take care of what's dangling off of there. If you're adding or subtracting something, that has to be taken care of first. So I'm going to subtract 3. So 7x equals 7. Divide both sides by 7. And we get an answer of x equals 1.